Namaskaram. In this session, we will discuss kernel and image of a matrix. The solution of last homework. Okay, as similar to kernel of a matrix, kernel of a linear transformation, so we can define the kernel or null space of a matrix. Kernel of a matrix A is a set of all column vectors X that satisfies the metric equation Ax equal to 0. That means kernel of A is equal to set of all X. X is a column vector, right? Set of all X such that Ax equal to 0. 0 is a zero matrix. And it is clear that kernel is always non-empty. Why? Because the vector 0. 0 means a vector like this, 0, 0, etc. 0. Suppose A is a m by n matrix. Then this is n by 1. Then A into 0 is equal to 0. So 0 vector is always belongs to the set. That's why kernel is always non-empty. Okay, next definition is image of a matrix. Image of A is the set of all vectors Ax for any vector x in the domain. The whole Ax's that is called that collection is called image of a matrix. For example, we consider a 2 by 2 matrix. A is equal to A11, A12, A21, A22, and x is any vector. That will be x1, x2. This x1 and x2 are arbitrary numbers. Okay. Then what about the image Ax? By matrix multiplication, Ax is equal to, so Ax is of the form by matrix multiplication. This is A11 x1 plus A12 x2, and the second term is A21 x1 plus A22 x2. Okay, and we can rearrange this Ax as like this. Here x1 is common, so you can write like x1 into the vector A11 A21 plus x2 into second vector is A12 A22. Clear? If you expand this bracket, expand this matrix, this gives the same element. Clear? X1 into A11 plus x2 into A12, and second term is x1 into A21 plus x2 into A22. Okay, then what about this vector A11 A21? This is nothing of first column of the matrix A. And what about this one, A12 and A22? This is the second column of the matrix, right? So we can write our Ax as like this: x1 into A1 plus x2 into A2. Okay, so what is the meaning? We have to find image of A. What is image of A? Image of A is set of all possible Ax's for any x. Okay, so for any x, for set of all Ax's means set of all x1 A1 plus x2 A2. A1 and A2 are fixed. They are the columns of the given matrix, and we can choose x1 and x2 as arbitrary. So this is like our C1 and C2. So what is this? Set of all possible linear combinations of A1 and A2. That means image of A is nothing. It is a set of all possible linear combinations of columns of A. That is called the span of columns of this matrix A. Clear? That is another result. Image of a matrix A is the span of columns of A, which is called column space of A. You got it? So image of A is equivalent to the column space of A, or column space means span of the columns of A. Consider a problem. Determine the kernel and image of the matrix A is equal to 1, 1, 5, 2, minus 1, 1. Okay. So to find the kernel, we have to solve the system Ax equal to 0. So it's a 2 by 3 matrix. So column should be 3 by 1. So we can choose x1, x2, x3. Okay. So we have to find set of all vectors of the form Ax equal to 0. So this is only two zeros. It's a 2 by 1 matrix, right? Because it's a 2 by 3 matrix, 3 by 1 matrix. So product should be 2 by 1. That's why we take a 2 by 1 0 matrix. So we have to solve the system. Expanding the bracket, we have x1 plus x2 plus 5x3 equal to 0 and 2x1 minus x2 plus x3 equal to 0. Next, you have to solve the system. You can use the Gauss elimination method. Okay, this is the matrix corresponding to the system. First, you have to make this term is 0 using this one. That means R2 goes to R2 minus 2R1, right? So what happened? Okay, so matrix is like this: 0, minus 3, minus 9. Now you can divide with a 3. That means R2 goes to R2 by 3. So this matrix is become 1 1 5 0 minus 1 minus 3. Okay, so what is the system corresponding to this matrix, this row reduced matrix? That is 1 1 5 0 minus 1 minus 3 times our x1 x2 x3 equal to 0 0. Okay, so we can expand this matrix. Okay, also it is clear that rank of this matrix is 2 and number of variables is 3. So this solution contains n minus r arbitrary. That means 3 minus 2, 1 arbitrary. Okay, so I'm going to choose x3 as arbitrary, so that it will be k. I'm going to choose x3 as an arbitrary number k. So what about x2 and x1? You substitute x3 equal to k in this expression, then x2 equal to minus 3k. Okay, so x3 equal to, okay, we assume that x3 equal to arbitrary k. So substituting x3 equal to k in this equation, that means x2 equal to minus 3k, and substituting x2 equal to minus 3k and x3 equal to k from this equation, x1 is equal to minus 2k. Now you are ready to write the kernel. So the kernel of the matrix A is equal to set of all vectors of the form minus 2k, minus 3k, k, where k element of R. Okay, so this collection is the kernel of this matrix. Yes, kernel of A is equal to minus 2k, minus 3k, k, where k is any real number. Next we have to find the image of the matrix. Okay, next we have to find image of the matrix A. And we know that this image is nothing, it is the span of columns of A. Okay, that means, okay, so image of A equal to span of column vectors, that is C1 into 1 2 plus C2 into 1 minus 1 and C3 into 5 1, where C1, C2, C3 are any real numbers. It is clear that all these three vectors are elements of R2, right? All the three vectors are belongs to R2, and we know that R2 is a vector space, so it is closed under linear combination. So it is a subset of R2. Clear? Whatever be the scalars, this span is a subset of R2. Okay, next we consider span of these two vectors, first two vectors. That means set of all C1 into 1 2 plus C2 into 1 minus 1, where C1 C2 belongs to R. It is clear that this set is a subset of image of A, because image of A is a span of three vectors. This is the span of only these two vectors. So it is clear that this is a subset of image of A. Clear? And then we consider these two vectors. Let it be B. B equal to set 1 2 and 1 minus 1. It is clear that it's a subset of R square. And is it linearly independent or not, these two vectors? Yes, they are linearly independent. Why? One of them is not a scalar multiple of other, so they are linearly independent. So what happened? We know that dimension of R2 equal to 2. Dimension of R2 equal to 2, and B is a 2-element linearly independent set. Then by result we know that B is a basis for R2. Right? B is a basis for R2 means what is span of B? That is R2. So this is nothing, this is span of B. Correct? So this is nothing, R2. So this set is R2. So what is the conclusion? The conclusion is from this set, this equation, R square is subset of image of A from this expression, and from this expression image of A is a subset of R2. Subset of R2. So what is the conclusion? Image of A equal to R2, because R square subset of image of A subset of R square means image of A must be equal to R square. Okay, so here image of A equal to entire R square. This is your homework. Thank you.